In this lecture we will talk about linked list. Linked list is a linear data structure composed of nodes, where each node possesses a reference to the other node. Each node also contains a data field of any primitive type like integer, double, or data field could be an object of certain class. In this picture we have a linked list of integer numbers. Note that each node has a reference to other node. To make it easier, we denote reference as an arrow which points to the following node. The last node has a value of null. This basically means that this node has no reference to the following node, therefore it is the last element of the linked list. Compared to arrays, linked lists don't have indexes, therefore it is not possible to access a certain position in linked list in constant time. For example, if we want to access the third element in the linked list, we would need to traverse through it up to the third position like this. This is a linear search which takes a linear time. Let's see how linked list is stored on a computer memory. In this picture we have a simplified view of computer memory. Let's say we are filling up the linked list with numbers of type byte. We add 1, 5, 0, 13 and 9. Each node stores some value and points to other memory address. Of course, each reference to another node uses some extra memory for storing the address of the node. For better understanding, we have just shown the stored value. The reference in this case is denoted as an arrow. Note that elements of linked list can be distributed sparsely on computer memory. This memory distribution is different compared to array distribution, where each element is next to each other. One must keep in mind that due to this type of memory distribution, sometimes it is tricky to apply the low-level optimization like caching. There are two types of linked lists, singly linked list and doubly linked list. So far we have been talking about singly linked list. The doubly linked list is different from a singly linked list in the way of traversing. Singly linked list can be traversed only in one direction, while doubly linked list can be traversed from the start to the end and vice versa. Such capability is possible due to additional node which points to a previous node. Doubly linked list is more flexible in comparison to a singly linked list, but requires more memory because each element in it stores extra node. Nonetheless, doubly linked list has one crucial benefit over singly linked list. It can remove the last element in constant time. If we would want to remove the last element in singly linked list, we would need to traverse the list up to the last but one element like this. Assign the next reference to null and delete the last element. Now let's talk about the same operation in doubly linked list. If we store the pointer to the last element of doubly linked list, we can access it directly in constant time. Then, via previous pointer, go to the last but one element, assign it next pointer to null, and delete the last element. Great. Now we understand the key concepts of singly linked list and doubly linked list. Next we will talk about deletion and insertion operations in both lists. Let's try to insert the element in sorted singly linked list. The value of the element to be inserted is 9. First, let's create an element with the value of 9 and the next reference assigned to null. We will need two pointers for traversing a list. Let's traverse the list up to the first greater element. We found 10, which is the first element greater than 9. To insert the element we need the previous pointer. Then we need to assign the next reference of previous pointer to node to be inserted. Then the next pointer of newly created node should point to the element with the value of 10, and that's it. We have inserted the element with value 9 in the right place. Now let's remove the element with value 7. We have to traverse through the list with two pointers up to the right element. We found the element of value 7, but we need a previous pointer. Then we need to assign the next reference of the previous pointer to the next reference of the next pointer. Finally, we can delete the unlinked node. This is our list after the removal. Okay, now let's do the same operation with the doubly linked list. First of all, let's insert the node with value 9 into the sorted doubly linked list. We need to allocate a memory for additional node, then we need to traverse from the start of doubly linked list up to the right place. Note that in this case we only need one pointer for iteration. So let's iterate through the list. We have found the right place for insertion. Now we can access the previous element and switch the pointers. Finally, we have the result. Let's remove the node with value 7. For this operation, one pointer is also enough. We need to traverse up to the node which stores number 7. We have found the right node. Now we can access the previous and next element of the node and switch the pointers. Finally, we are able to delete the unlinked node. This is how our list looks after removal. The key points of this lecture would be the following. Linked list is a linear data structure which has a sequence of nodes where each node has a reference to the next element. There are two types of linked lists, singly linked list and doubly linked list. Doubly linked list is more flexible compared to a singly linked list, since each element in it possesses additional node to a previous element. Linked lists are effective in adding and deleting elements at the start and the end of the list. Addition and deletion in the middle of linked list takes constant time but requires linear search to find the place of addition, deletion. Thank you for your attention.